In the previous video, I used algebra of limits to show that limit n tends to infinity n by n square plus 1 is equal to 1. So this is the exercise for you. Use sandwich theorem. Okay. In this video, I will show that limit n tends to infinity r to the power n equals to 0 if mod of r is less than 1. But what if r equals to 1, r greater than equal to 1, r less than equal to minus 1? Hmm? So first see this case. If r equals to 1, then r to the power n is 1 to the power n is equal to 1. This is a constant sequence. So limit of n tends to infinity r to the power 1 equals to 1. Okay. If r equals to 1. If r is greater than 1, then we have something like this: 1 to the power n, 2 to the power n, 3 to the power n. So this keeps on increasing. This keeps on increasing. So this will diverge to plus infinity. If r is less than minus 1, then we have minus 1 to the power uh, sorry then we have something like minus n to the power n s n. See, r is less than minus 1, so r will be of minus 1 into some s, where s is greater than 0. How this is to see this? R is equal to minus 2, then r can be written as minus 1 into 2, where 2 is greater than 0. So we have used this. So r is less than minus 1 implies r can be written as minus 1 to minus 1 times s, where s is positive. So r to the power n becomes this, and minus 1 to the power n, minus 1 to the power n is what? Minus 1, 1, minus 1. So oscillatory. So this is an oscillatory sequence. So this is also diverging, but this is not diverging to minus infinity. This is an oscillatory sequence. Okay, uh, oscillatory oh. Anyway, I have forgot the spelling. So we have to show that limit n tends to infinity r to the power n equals to 0 if mod of r is less than 1. Okay, so let's see this case. Now we have to show that r to the power n equals to 0 limit. So we have to show that mod of r to the power n minus 0 is less than epsilon for some n greater than k, for all epsilon greater than 0. This is to be shown. But see this, r to the power n minus 0 less than epsilon, uh, we already know that limit of n to the power infinity 1 by n equals to 0. Okay, and mod of r is greater than 1. This will imply that mod of r to the power n, mod of r is less than 1. So mod of r and r to the power n is less than 1, right? So if mod of r to the power n is less than 1, then we have 1 by mod of r to the power n is greater than 1, right? Or also 1 by mod of r is greater than 1. If we can show that 1 by mod of r is less than, oh sorry, mod of r is greater than 1, this is not important. This is not necessary. We show that we have that 0 mod of r is less than 0. This is the property of absolute value function, right? So mod of r is greater than 0. Remember this. And then okay, now see this, limit of n tends to infinity 1 by n is equal to 0. So if we have a sequence such that 0 less than mod of r less than xn, such that limit of xn equals to 0, then using sandwich theorem we can say that limit of r equals to 0. So we have to construct such a sequence. But we have a trick in this case. Mm, we have a trick in this case is what? That 1 plus a to the power n is greater than n a for all n natural number. Okay, so what is the trick? The trick is that we take 1 by r to be 1 plus a to the power n. Then what happens? Then mod of r equals to 1 by a to the power a n. Okay, sorry, this is, and this is what happens. So mod of r to the power n equals to 1 by 1 to the power n plus 1. Now is 1 by a less than, see, r is, mod of r is less than 1. So mod 1 by mod of r is greater than 1. Now, is this greater than 1? Obviously, because 1 plus a is positive number. So, and 1 plus positive number is obviously greater than 1, right? So we can take this. So r to the power n is equal to 1 by 1 plus a to the power n. Now r to the power n minus 0, and use properties of absolute value, then mod of r to the power n equals to mod of r to the power n equals to 1 by 1 plus a to the power n. So mod of r to the power n minus 0 is less than mod of r to the power n, but mod of r to the power n is less than 1 by 1 plus a to the power n. Again, 1 plus a to the power n is greater than 1 by a. That means it is less than 1 by 1 by n. So we have 1 by 1 plus a to the power n is less than 1 by n. Now we have to show that 1 by n by a is less than epsilon. So this happens when, so we have to show that 1 by n is less than epsilon. For which n? We have n is greater than epsilon, or n to be greater than 1 by a epsilon. Okay, so let k to be 1 by a epsilon plus 1. Then for n greater than equal to k, r n minus 0 is less than epsilon. Okay, see, we have that something like this is happening uh, after which value of n? After n less than greater than equal to, for n greater than equal to a epsilon. So we are starting from this value, and obviously if this is, if for this and this is happening, for this and it is also happening, right? This occurs. So we can say that mod of r to the power n minus 0 is less than epsilon for all n greater than equal to k, where k equals to 1 by a epsilon plus 1. Okay, so I hope this is clear. So this simply implies that limit of r to the power n equals to 0. Okay, thank you.